Problem number 13, let S be the set of real solutions x, y, z of the following system of equations. These three equations for each x, y, z in S. Define m of x, y, z equals 2000, open bracket, absolute value of x plus absolute value of y plus absolute value of z, close bracket. Determine the maximum value of this for all of these things. Okay. So this over this is not good, but if we consider reciprocal of each equation, for example, the first one is 1 plus 4x squared over 4x squared is 1 over y, and now that's better because we can write it for 1 over 4x squared plus 1 over y, because we have 1 over 1 over x. So we consider, for example, x1 is 1 over x1, y1 is 1 over y1, and okay, so because if we write 1 over 2x squared plus 1 equals 1 over y, because to get rid of this over 2, we can consider a 1 over 2x1, 1 over 2y, 2x, 2y, and z equal to 1 over 2z1, 1 over 2z. Now, here from the first equation, we say, okay, this x1 squared plus 1 equal to 1 over y is 2y1. And similarly for the second one, if we write y1 squared plus 1 is equal to 2z1, and z1 squared plus 1 equal to 2x1. If we add all these three equations and take all things to left hand side, it will be x1 squared plus 1 minus 2x1 plus y1 squared. Look here, this one, this one, this one. Also, you can write for y1 squared plus 1 minus 2y1, this one, this one, this one. And the last three terms, z1 squared plus 1 minus 2z1 equal to 0. And we can say x1 minus 1 squared plus y1 minus 1 squared plus z1 minus 1 squared equal to 0. So we can say x1 equal to y1 equal to z1 equal to 1. So here we know x is what? X is 1 over 2x1 here. And because there are 1, so we can say x equal to y equal to z equal to 1 over 2. Now here, if we add all of them, 1 over 2 here plus 1 over 2 plus 1 over 2 will be 3 over 2. And if we multiply, they will be cancelled. 2, so it will be 3000. Okay, problem number 14. Assume that t is a positive solution to the equation this. Determine this. Okay, so as you can see, if we write t like here again, it will be root, we continue, 1 plus 1 plus until here. So if we write it again and again, we can conclude t is congruent to 1 plus root 1 plus root 1 to square root of 1 infinity. Now here we can say it is also t. If you raise to the power of 2, it will be t squared equal to 1 plus t. So here we can say, okay, we know t squared is what? Now we want to, this idea also is useful in AME problem I saw in American Math Olympiad. So t cubed is what? You say multiply both sides by t plus t squared. Again, replace t squared by 1 plus t. We try to decrease the powers. It will be 2t plus 1. And t to the power of 4, we multiply both sides by t. It will be 2t squared plus t. 2t squared will be 2 times this plus 2t plus t. It will be 2 plus 3t. Now, if we replace t to the power of 4, t to the power of 4 equal 2 plus 3t minus t cubed is 2t plus 1 minus t plus 10. Okay, so it will be what? Negative 2t, negative t, and 3t, they will be cancelled. And 2 minus 1, 1 plus 10, 11. So the answer is equal to 11. I released some problems exactly like this for Stanford Math Tournament 2022. If you solve them, you could easily solve this problem.